So if you have f of u of x, we'll write it as f of g of x. How's that? So Isaac doesn't laugh too much today. And you want to take the derivative of f of g of x. It's the derivative of the outside with the inside left alone times the derivative of the inside. Okay? G prime of x times f prime of g of x. And so I'll set it up two different ways now to try to scaffold where we need to be. I'll set it up without the boxes. What is the derivative of the inside? 2 times, what's the derivative of the outside? 4u, or that thing, to the third. So we get 8 times 2x minus 3 to the third power. So you should be able to, from your work yesterday on your assignment, be able to now look at the chain rule and be able to do it rather quickly, okay? I'll set up the boxes here to bring us back. What is the outside function? 6u to the fifth. What's the inside function? X minus x squared. So when we take the derivative of the inside, we have, and the derivative of the outside, right. Now I can distribute this 30 through to the 1 minus 2x, or we could just leave it out front. I'll have 30 times 1 minus 2x times x minus x squared all to the fourth power. Sometimes you may choose to look at the problem and say, I'm not going to set up the boxes. I'm just going to do the chain rule nice and simple. Other times you might say, well, you know, I need to set up the boxes. It's challenging for me. This is one where I would not set up the boxes. What's the derivative of the inside? 10x, right? So I'll have a negative 40x when I multiply that. What's the derivative of the outside? What's the derivative of secant? Secant tangent. So secant of 5x squared, tangent of 5x squared. Derivative of the outside times the derivative of the inside, or derivative of the inside times the derivative of the outside with the inside left alone. Then you have this situation where you might say, oh, that's more challenging, so I'll set up the boxes. What's the outside? Negative 5u to the negative 7th. What's the inside? What's the derivative of the inside? Do you understand when the derivative of the inside is 1, that doesn't have any impact on the answer, does it? So from the very beginning, you can see that this derivative is going to be 35 over u to the 8th, or simply 35 over x plus 5 to the 8th power. So many people can look at that problem and do it very quickly because the derivative of the inside is 1. I'll try to make the point once more to you. If I have this problem, x plus 1 to the 100th power, because the derivative of the inside is 1, the derivative is simply 100 times x plus 1 to the 99th. But if the derivative of the inside is not 1, say you have 2x plus 1 to the 100th power, which is what I gave you today, correct? Then the derivative is not simply 100 times 2x plus 1 to the 99th, but rather 200. Okay, see the difference? They call it the chain rule because there are multiple things at work. So if anybody thinks about kind of a pulley system, you know, as one, what happened there? Do calculus and the smartboard gets stupid. Come on, buddy. So if you can think of, you know, whether you're in a science class or an engineering class or something of that nature, when you have two pulleys that are working together, you notice that depending on the diameter, one pulls at a certain rate and the other one pulls at a certain rate, and that changes the problem as a whole, okay? That's why they call this as a chain rule. You have different rates that are occurring. So they call it the chain rule because of this piece that we've seen here. So you guys have taken the easy stuff. Let's dig in. Let's see the difficult stuff. Now it's time to lean in. I will do my best to explain it, and it will not be enough for some people. I'm sorry. What do you notice about 5? You have to see it, otherwise I can't help you. I have the 2x on the outside. So what you have to understand in this problem is this is the chain rule in cooperation with the product rule. You understand that? This derivative requires the use of the chain rule. The entire piece requires the use of the product rule. My best way to help you understand this is to think about order of operations. That's all I can do, folks. If I were to plug something in for x, you would take 4 minus x and take it to the fourth. You would take 2 times x, and the very last thing you would do is then multiply those 2 pieces together, correct? So therefore, I start with the product rule. Here's the difference. Suppose I had 3x times sine of x raised to the 10th power. Can everybody see that that involves the chain rule? Notice what you do. You plug in something for x, multiply it by 3. Plug in something for sine, okay? You multiply them, then you take it to the 10th power. So this also involves the product rule and the chain rule. But I would start by setting up the chain rule, because what's the last thing you do? You set that entire piece up to the 10th power. See the difference? Order of operations here, the last thing I do is multiply them together. So which one you decide to set up depends on your order of operation. You must think that through. You must think that through. Okay? I'll end with this description. 2x plus 1 is equal to 9. You all know how to solve that, right? But you may not know why. Think about your order of operation. You plug in something for x. What's the first thing you do? Multiply by 2, then add 1. So because that's the last thing you did, that's the first thing you undo. See that? You've been doing it your entire life. So we are trying to see that in the same sense. That's why you subtract the 1, then divide by the 2. So we set it up. F prime times G plus G prime times F. Here we go. Let's see if we can handle it. What is the derivative of F? We will call F 2x. 2. Everybody good with me so far? Times 4 minus x raised to the 4th power. Plus, I'm going to leave the 2x alone. So 2x times, now I need the derivative of 4 minus x to the 4th, correct? At this point, most people set up the boxes, which is fine. U to the 4th, 4 minus x. Four u cubed, negative 1. Yes. I'm going to call this F. I'm going to call this G. So I'm actually writing the product rule as F prime G plus FG prime right now. That's what I'm doing. Yeah. I just use the commutative property of multiplication there. So I'm just putting that down right away. Okay, so I get negative 4 times 4 minus x to the 3rd power. Is everybody in agreement there? So times negative 4 x minus, or 4 minus x to the 3rd power. We're not done. If I rewrite this, I get 2 times 4 minus x to the 4th power minus 8x times 4 minus x cubed. The truth of the matter is that is the derivative, but that is not the form in which I'll accept your final answer. Why? Because they never leave it like that on the AP exam, nor do they leave that in the answer key for your book. anytime you use the chain rule in cooperation with the product rule, or the chain rule in cooperation with the quotient rule, you must factor it, and you can see what happens. What is the common factor I can remove from both of these? 2 times 4 minus x to the third. If I take out 2 times 4 minus x cubed, what is left there? 4 minus x minus what's left here? 4x. You see that? So now I have 2 times 4 minus x cubed times negative x and negative 4x make. So I have 4 minus 5x. This would be the acceptable answer for f prime. Yes. Sorry. Thank you. Got ahead of myself. If you multiply the 2 through here, you could write as 8 minus 10x. That would be fine. But this is generally how the answer will be expressed. Okay? You see the trick, right? Let's look at another example. Sine squared of 3x. Think about your order of operation. You plug in something for x. What do? Multiply by 3. After you multiply by 3, what do? You take the sine of it. After you take the sine of it, then you square it. So this is the same thing as sine of 3x quantity squared. That's what this means. Okay? Those mean the same thing. So what's the last thing you do? You square it. So therefore, the beginning of our structure will be the chain rule. So if the last thing I do is square it, what is the outer structure of this chain rule? U squared. What's the inside? Sine of 3x. What's the derivative of u squared? 2u. What's the derivative of sine of 3x? What do I have to use? What do I use to find the derivative of sine of 3x? The chain rule. Sine of 3x. That's been said before. We have sine of u. We have 3x. Derivative of sine. Cosine of u. Derivative of 3x is 3. So what's the derivative? So that's what I drop into this box. 3 cosine of 3x. So this was just our side work to come up with that derivative. Now we multiply this together. Can I take the 3 times a 2? Yep. 3 times a 2 is 6. What is u? Times the sine of 3x times the cosine of 3x. That's the derivative. That's the chain rule twice. So you saw the product rule with the chain rule. You saw the chain rule twice. Flip it over. Okay, we're going to skip these because you're good to go with them. Letter A. Letter A. How should I set this up? Product rule. Very good. Very good. I have F and I have G. What is F prime? Negative 6x times cosine of 4x. Easy so far. Plus. Now I leave the negative 3x squared alone, correct? So plus negative 3x squared times, I need the derivative of cosine of 4x. Chain rule. I am going to choose to not write the boxes because we are ready for it. Derivative of cosine of 4x. Watch how I do this. What's the derivative of the inside? 4. What's the derivative of the outside? Negative sine. So my good friend Josie said, I'm writing the boxes. Josie, that's fine. I want to try to push some of you at this point to start to see that. I could save some time and space by finding the derivative cosine of 4x. I can see, oh yeah, that's negative 4 sine of 4x. Okay, there's going to become a point where that's going to become second nature. All right, I got a lot of stuff here. Negative 6x cosine of 4x, and it's a plus 12x squared sine of 4x. My teacher told me that if I use the product rule and the product rule and the chain rule together, I have to take out a common factor. So I'm going to do that. What's the common factor that we can take out? Negative 6x. Take out negative 6x, what are you left with? Cosine of 4x plus minus, thank you. It's all right, Riker. You're right 98% of the time. Minus 2x sine of 4x. That's your derivative. Maya asked a really good question. The question was, why do I start with the product rule? Do you understand that it does require the chain rule? Okay, so if I plug in something for x, I would first multiply by 4. I would then take the cosine. I would square the x and multiply it by negative 3. Then in the very end, I would take those two things and multiply them together. Yeah, that's how you try to think of it in terms of your order of operation. Okay, so we're going to do letter C and letter D today, and we're going to quit with that. Tomorrow we'll do B and then this back piece here, which is really cool. And you'll have the rest of the time to work tomorrow, and you'll have time on Friday. But let's try to do this together. Get ready for letter C, and you're actually going to try letter D on your own. What do you think? Letter C. Quotient and chain. Quotient and chain. What do I start by setting up? Do I set up the chain rule or quotient rule? Quotient rule, because that's the last operation. You would plug something in for x and do the top. You'd plug something in for x, do the bottom. And the last thing you would do would divide. So therefore, we're going to set up f prime g minus g prime f all over g squared. Riker just gave a gasp, and I know why. Why did you just give a gasp? Okay, I thought you did because you understood right away that when you do f prime, you have to start with the chain rule right away now, don't you? Yeah. So when people say you start with the chain rule, what I'm talking about with is the outer structure. But look, it says f prime, so you got to take the derivative of the top right away. Everybody agree we're going to have to find the derivative of the top and the bottom at some point? So let's just make some space and do that. So I'm going to invade this space over here, and I'm going to do that one and that one. So I've got u to the 4th, and I got 3x minus 5. So I'm finding the derivative of the top right now, Marty. u to the fourth. Derivative of u to the fourth, 4u cubed. Derivative of 3x minus 5. Multiply them together. 12u to the third. Or 12 times 3x minus 5 raised to the third power. Okay, we try the next one. How do you set up the next one? U to the sixth. Sam did 6u to the fifth right away. We've got 2 minus x. Derivative is negative 1. Negative 6. Sweet, good job. So we're going to set this up. Okay, this is a lot of work. I'm not, and I want to be clear, I'm not showing you anything that you may not see in the future. What I'm showing you is totally within realm of what you can see on the test, as well as the AP exam, without a doubt. This is a reasonable question for the test. So what I do is I take this, I have f prime, that's this guy right here, 12 times 3x minus 5 raised to the third. What goes after that? 2 minus x to the sixth. Minus, now what? So that'll be a plus 6 times 2 minus x to the fifth, right? Times to the fourth. All over what? Ooh, that actually makes me happy. Why? What can you cancel? You could factor out a 2 minus x to the fifth on the top, right? And it would cancel with how many on the bottom? Yeah, 5 of them, leaving you with 7. So you're going to end up with 7 of these down here. These are all going to be gone here. And how about here? We have 1 left. Well, that was kind of fun. So I'll write what I have now in the numerator, and then we can look towards our common factor. 12 times 3x minus 5 to the third times 2 minus x plus 6 times 3x minus 5 to the fourth. All over 2 minus x to the seventh. So that's great. Cool. Not done. What can you factor out of the top? What's the common factor out of the top? 6 times 3x minus 5 to the third. Tully? Eight other people are asking the same thing. Okay. Good question. Yep. So we have subtraction within the quotient rule, and we have a negative here. Cancel to make the positive. Excellent question. If I factor out a 3 or a 6 times 3x minus 5 cubed, what is left here? 2 times 2 minus x, right? Or 4 minus 2x plus, what's left there? 3x minus 5. And that's all over 2 minus x to the seventh. So what could I combine together? Yeah, the 4 and the negative 5 make negative 1. And the 3x and the negative 2x make 1x. So I'm going to write it as an x minus 1. All over 2 minus x raised to the seventh power. Now, I want to be clear so you all have a great understanding of what we're doing. The very beginning was calculus. The rest of it was algebra, your beloved algebra that you so love and hold dear. Trust me, folks, people get the calculus right most of the time. It's the algebra that kicks them in the butt. Algebra isn't always easy. So just keep that in mind. This is your derivative. You try letter D on your own, and that's what we end with today. Try D on your own. Don't be afraid. Try it. Even if you don't know what to do, try something. You're going to learn more if you just try something. Go. All right, folks, let's bring you out of your confusion. I look at this and I say to myself, first of all, guys, just ignore the -8. It's just a constant. It has no bearing on the problem other than we'll multiply the final answer by -8. All still included, but I want you to understand that sometimes the -8 throws people off. I plug in something for x and multiply by 4, subtract 2. Then I take the sign of it. After I take the sign of it, then I raise it to the 4th power. So therefore, the chain rule is the outer structure. And how you set it up is -8u to the 4th. So if you got that, good for you. What's on the inside? Sine of 4x minus 2. Folks, if it would help you, you could rewrite it as -8 times the quantity sine of 4x minus 2 all raised to the 4th power. That could be another way in which you would write it, and then maybe you see the -8u to the 4th. That makes more sense? Good. Glad to help you there. Derivative of -8u to the 4th. And 32u cubed. How do I find the derivative of sine of 4x minus 2? Good. Chain rule. Asher started to work it out without the boxes. I'm going to write the boxes because I can see some brains getting a little confused. Sine of u and 4x minus 2 is what I set up. Derivative. So everybody agree it's 4 times the cosine of 4x minus 2? 4 times the cosine of 4x minus 2. Can I draw that arrow to remind me that that's what I plug back in. So now I'm going to multiply these two things together. These two things have to be multiplied together. -32 times 4 is -128. Then I have u. U is sine of 4x minus 2. Does the cube go over the 4x minus 2 or over the sine? It goes over the sine. Times the cosine of 4x minus 2. Let's answer the question. Can you ask it again? I think the first question was, why do I put the 3 over the sine and not over the 4x minus 2? Because this is u. You're cubing that whole thing. So if you want to put the 3 at the end, then you're going to have to put a double set of parentheses. That's what that means. You are cubing that. So if you're going to cube that, then you have to put the 3 over the sine. You're cubing the whole thing. If you put the 3 just over the 4x minus 2, it means you're taking 4x minus 2 cubed and then taking the sine of that, which is not what you're doing. This is your derivative. A beautiful thing. Just think if you were to do f of x plus h minus f of x all over h, limit as h goes to 0, that would be extremely challenging. So there you have it set up. I have a worksheet for you with plenty of problems. I would encourage you, there are some easy problems on there, but there's also some complicated ones. I would encourage you to get a jump on it. Here you go.